Let's have a look at the noise falloff, which hides under mobs. Falloffs, noise falloff. Let's wire this in here, highlight it, and we can immediately see something happening there. So let's go to the remap tab. As always, you have a remap, which you can use to fit the values that we generate in order to make them more contrasty or less contrasty, or whatever you like, basically. So this works a bit like curves and levels in any image editing application. So let's check fit here and increase the contrast a bit, like so, and head back to our primary tab here. So this has controls for generating a noise, and by default it is set to generate a Perlin noise. And if we increase the scale a bit, say to 10, we can see it undulates really nicely across the image. And you have all the standard controls for working with your noise. So frequency basically is the same as the transform. So by increasing that, we will get a finer noise. By decreasing that, our noise will get bigger. But I usually tend to use those transforms directly. Also, we can dial in the amplitude, that means how strong the noise is, how big the values are that the noise generates, and we can dial in octaves and persistence in order to give that noise a bit of a coarser look, like so. Let's dial it back to the default values and see what else we have in here. So we can generate a Perlin noise, a simplex, which is a variant of the Perlin, which is a bit more efficient, but in general yields the overall same structure and same appearance. We can generate a Wally with subtracted point values, and let me just dial this in with the remap here, and maybe so you can see it better, I will increase my number of copies here to say 80 by 80. Zoom out a bit, and in my noise settings also increase the uniform scale to say 100. So now you can see what's happening here. Let's decrease our distance. So now I think it should become clear. What we're generating here is this cellular noise structure. And when set up to F2 minus F1 mode, we get low values at these cell edges and higher values towards the cell centers. Let's set it to Wally F1, which will generate those roundish shapes here with low values at the cell centers and higher values at the edges. And also, finally, let's have a look at F2, which yields this appearance. The way that whirly noise works is you scatter points in space, and for each position, you check the distance to the closest point, that's Wally F1, and you just write the distance to the closest point into those position values. So here is one scattered point, here would be another, and here and so on. Wally F2 is the distance to the second furthest points from each position, and Wally F2 minus F1 is the difference of both values, yielding this structure. So that's whirly noise. We've got a mosaic noise. Let's scale that back a bit, and also let's make the tile size uniform like so, which will yield those mosaic-like structures here with those cells. We will have a folded noise, which is basically the absolute values of a simplex noise, so we won't have negative values in here. We have a warped simplex, which is a warped version of that absolute value noise that you just see, and we've mixed in the minima of different noises, which results in this weirdish appearance here. So a few noise presets here. We're looking at adding other presets for the future, but that's just the basic set for now.